what's up, YouTube? I think that we're live now. Let me make sure about that. What's going on? It's great to see you all again. Let's go. So today is day 3, restarting this math stream. We're still working through Frale, chapter 1. This is going to be a quick little linear algebra practice sesh. I just lost my iPad pencil, but I guess that's okay. Today is January 26th. I'm JC Practices Math, and today I created this nice little exercise table. I like to write these for any math book to track all the exercises in the book and which ones I've solved already and which ones I still need to solve. So we've been solving the first problem from the first section, the first problem from the second section, the first from the third, first from the fourth, first from the fifth, sixth, seventh, eighth. And I keep doing that. I try to do that until I get stuck. And if I get stuck, then I restart. Last time we got stuck in section 2.1. Today I want to stay in chapter 1 for now. For this practice sesh, we'll be doing now a third lap through chapter 1. So we're going to be starting vectors in Euclidean spaces, then we're going to go to the norm and the dot product, and then some other topics that, we'll see as we go. So, we start to learn about matrix algebra, and all sorts of other pretty cool elementary kind of topics. So this is now going to be Frale 113. Let's see. What is Frale 113 again? I don't think I've actually solved this one privately. So this one is new for a live problem solving sesh. Heck yeah. So Frale 113, V is I plus 3j plus 2k. W is I plus 2j plus 4k. And now our goal is to compute v plus w, v minus w, and then we need to sketch these in a coordinate grid. We're going to sketch VW, V plus W, and V minus W. So this is just another notation for, I is 1, 0, 0. J is the vector 0, 1, 0. These are the orthogonal vectors. And K is 0, 0, 1. So if we multiplied 3i, then we have 3, 0, 0 plus... I plus 3j. J is 0, 3, 0, and then 2k is 0, 0, 2. So this is going to be 1, 3, and 2. I mean, it's actually exactly like the order of how they're written out here. W is 1, 2, and 4. And now I can go ahead and sketch those. So V is at 1, 3. Let's give it a different color just for funsies. Here is V. Give it a different color. V is red. And now W, maybe W is the blue one. 1, 2, comma, 4. Oh, wait. Oh, what am I doing? 1, 3, 2. Oh, we need to sketch this in 3-dimensional space. Oh, shoot. Okay. What am I talking about? I plus 3j plus 2k. Yeah, okay. All right. I take it back. 3D space. Awesome. So, I'm going to remind myself, but I'm pretty sure I, J, and K directions. So, 1, 3, this is like X, Y, and Z is another way to put this. So 1, 3, should think of it like, here are those parallel lines. So there's I plus J, and then a parallel line of 2K. It's going to be about this distance. I'm going to get some muscle memory. It's about that far away. Like, what is it again? 2. Okay. Yeah, it's like about 1, 2. It's right about here. So, what color did I choose? Red. This is a good problem. This is a good problem. I really like Frale. I think Frale is like a really nice... it is a nice level of rigor, I think. I think Frale is great for an introductory linear algebra book. It's like, it's written for math majors. It's so clear. Hey, good morning, Leo. Good to see you, dude. Good to see you, man. All right, so this is the third problem, and we're already sketching in three-dimensional, in R3. Like, that's pretty freaking cool, I think, for an intro book. It's so much nicer than Strang, in my opinion. Hot take, I know. So we have 1, 2, 4. So now the blue vector, 1 in the I coordinate, 2 in the J. So I'm drawing little parallel lines so that it helps us see the three-dimensional coordinate space. I should have spaced these way out, but I didn't. Oh well. 1, 2, 4. Oh yeah, 4. Okay, so we want kind of like 1, 2, 3, 4, right? Something like that. So we have V, W. Unfortunately, I'm also just passing through again today. Well, thanks, man. Hit the like button, of course. If you can, leave it on mute. That'd help me a whole bunch, but no pressure. Bro, hope you're doing well. Thank you for popping by. Cool. But of course, no pressure. Now, let's do V plus W. V plus W is 2, 5, 6. Okay. 2. 1. Why do I feel like I got... let's restart. Let's restart. Oh no, because it's going to be hard to fix our coordinate grid. When we added these, oh no. V is correct. W is correct. I started thinking that I didn't add them together. V plus W is the first time that we're adding. We're fine. We're fine. Okay. 2, 5, 6. So we're sketching 2, 5, 6 for a reminder. Okay. 2, 5 is going to be 1, 2, 3, 4, 5. Let's make all of those yellow for consistency. 1, 2, 3, 4, 5. And I think that all of these, I think all of these are better written if they're correctly 1, 2, 3, 4, 5. If they're written, if they're drawn kind of parallel to, if they're drawn parallel to the J line, they're still a little skew, but who cares? We're drawing 2, 5, 6. So 2, 1, 2, 3, 4, 5. So if we draw a parallel-ish lines here, then there's that parallelogram. 2, 5, 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6 in the K direction. How do we see this correctly? I have a hard time. Hey, kitty cat. Hello, kitty cat. Yeah, I'm just gonna try to wing it. 1, 2, 3, 4, 5, 6. It's something like that, maybe a little bit more, I feel. 1, 2, 3, 4, 5, 6. But it's something like this. 2, 5, 6. This is V plus W. And now the final one is V minus W. Let's give that another color, purple. V minus W is going to be 0, 1, negative 2. Alright, so 0, 1, negative 2. 0, 1, and then negative 1, 2. It's so hard for me to see 3D space, honestly. Oh wait, shoot. 0, 1, negative 2. So 0 in the I component, 1 in the J, and then negative 2 in the K component. 1, 2. Something like this. So that one, it's hard to see, but that one is kind of going away from you. If you are the camera, like looking at this thing, it's going into into the page or the iPad. That's a pretty cool problem, I think, for for elementary linear algebra problem 3. I like it. I like it a lot. All right, so Frale and Biergaard 113 is done. Let's go. Frale and Biergaard 1.2.3. What is this problem about? 1.2.3, the norm and the dot product. This is about the norm and the dot product. Ooh, Luna! Hungry! Hungry! Meow! Hungry! 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 Hungry kitty! The auto food dispenser just went off, and she's very, very food motivated. She's a very food motivated kitty. Okay, so this one says that U is -1, 3, 4. V is 2, 1, -1. And it's going to ask us to find, in this case, U plus V. The norm of U plus V. Right? So, well, U plus V is 1, 4, 3. 1, 4, 3. If you add those two vectors together. And then the norm is the square root of the sum of squares of a vector. So this is 1 plus 16 plus 9, which is square root of 26. I feel like we just got square root of 26 recently. So that's interesting. Oh yeah, okay. U is -1, 3, 4, and then this one is 1, 4, 3. So the coordinates are kind of swapped, but it's the same numbers. The absolute value of the same numbers, right? -1 and 1, the squares are both going to be +1. All right, whatever. Let's keep moving. F and B 1, 3, 3. Let's see how far we get. I don't have that much time today. I have to be done at 9:55 and it's 9:32. So let's see. Let's keep moving. 1, 3, 3. 1, 3, 3. Let's practice. In this one, A is the matrix -2, 1, 3, 4, 0, -1, 4, 0, -1. B is the matrix 4, 1, -2, and 5, -1, 3. And then there's other matrices C and D, but we don't need them. So now we're computing. It's asking us to find, let's use blue. Blue looks a little nicer, I think. What is A plus B? Well, you just add component-wise. This is an easy one. -2 plus 4 is 2. 1 plus 1 is 2. 3 plus -2 is 1. 4 plus 5 is 9. 0 plus -1 is -1. And -1 plus 3 is 2. We're done. F and B 1.4.3. these problems are still easy, but even in these sections, the problems will get harder later as we do more and more laps through this book. The first problems in a math book are usually just kind of like getting you to learn the definitions and the basics or something. Like this one is already going to get a little gnarlier. Find a row echelon form and be the reduced row echelon form of A equals. This one is already a 4x4 matrix, so it's just going to take a little longer. 0, 2, -1, 3, -1, 1, 2, 0, -1, 1, 2, 0, 1, 1, -3, 3, 1, 1, -3, 3, 1, 5, 5, 9, 1, 5, 5, 9. So we solve this through row reductions. 0, 2, -1, 3. Why am I rewriting this? Because I got nothing better to do. Because AI took my job. 1, 1, -3, 3. 1, 5, 5, 9. Let's do some row reductions. I want to... The easiest row, I think, would be to work with 1, 1, -3, 3 in the top row. So I'm swapping that one and the first row. 0, 2, -1, 3. We don't need to track our moves in this one, so I'm just going to also add the second and third. I'm going to add these two rows to get a 0 in the second row. So 0, 2, -1, 3. So hey, look at that. The second and third rows of this new matrix are identical. So that's good. It's going to be easier to work with. And then the final row, 1, 5, 5, 9. We can add the second and last rows together. Or maybe take 1, 5, 5, 9 and subtract this one, the first row of the new matrix. So 1 minus 1 is 0, 5 minus 1 is 4, 5 minus -3 is 8, and then 9 minus 3 is 6, right? Cool. So, 1, 1, -3, 3. I'm going to keep 0, 2, -1, 3. I am going to move the third row to the last row and subtract the second to get zeros. And then this other one, 0, 4, 8, 6. Let's do it in 2 steps. Make sure we don't make any silly mistakes. And use this really neat feature to duplicate. And now I can rewrite this row. So we want to subtract 2 times the second row. 0 is still 0. 4 minus 4. 8 plus 2. And 6 minus 6. Right? Cool. Let's keep doing this nice fancy duplicate feature. Now I'm going to divide this row by 10. Oh, wait. Here. This one is in I'll say it's in row echelon form. Because it's not upper triangular, but it's not exactly upper triangular form, but there are no I don't know how to put it. Below any pivot number, which then you have to define what a pivot number is, there's all zeros. Like the first non-zero entry of the first row, everything below it is 0, and then we're going to look for, there should be a second. I don't know how to define row echelon form very well, y'all. I should be able to, but I'm not going to right now. Now we are trying to zero out as much as we can. All right, so we got that third row to be 0, 0, 1, 0, and then we can add and subtract that row from the others to zero out everything above it. And then I think reduced row echelon form, for it to be unique, we need ones in the leading, ones in the pivot spots. So reduced row echelon form would be 0, 3. Oh wait, what am I doing? Divide this by 2, the second row by 2, and we get 0, 1, 0, 3 halves. Then we have 0, 0, 1, 0, and 0, 0, 0, 0. This, I believe, is the reduced row echelon form. Notice it's unique. The reduced row echelon form of the original matrix. So, we're done. That was FNB 143. I will check my answers someday, at some point, but for now, I'm just going to trust that I got these right. I feel pretty confident about it. FNB 1.5.3. I don't want to confuse anybody out there. If only I spent time on linear algebra rather than calculus. Why do you say that? Priyanshu, nice to meet you. By the way, hit the like and subscribe if you're enjoying this. Why do you say that? I mean, you're spending time on linear algebra right now by hanging out with me, dude. What's up? All right, in problem 153, I remember this plan. It says A, find A inverse if it exists. B, express as product of elementary matrices. So, in this problem, A is 3, 6, 4, 8. 3, 6, 4, 8. Okay, so to solve a problem like this, we want to write this modified matrix do a series of elementary operations, and if possible, row reduce this to the identity with the inverse matrix on the right hand side. I really couldn't understand much of it. Oh, really? Yeah, linear algebra is gorgeous, dude. Here's your chance. It's not too late. You can learn it now. Even if it's just for fun, dude. Linear algebra, it's my favorite. I like linear algebra. So, I see that the second column is double the first column, so I know for sure that this matrix is not invertible. But we can see it. We can see that that's what's going to happen. The book has not introduced... really? Matthias. Me too. Linear seems pretty abstract to me. That's what I love about it, personally. It depends on your teacher, I think. I had a great teacher, and man, like, I just freaking loved it. Okay, so we could do this by... Our goal is to get the identity matrix on the left. So if I divide the first row by 3, then I get 1, 2, 1/3, and 0. What book did you all work out of? Do you know? You had fun doing calculus for most precious days. Okay. Calculus is okay. I mean, for me, I'm all about that linear algebra, y'all. Like, I just freaking love it. Let's divide the second row by 4. So this is 2 elementary matrices. 2 elementary operations, but that's fine. 1, 2, 1, 3, 0. And the second row is now zeros. Doesn't even matter what's on the right-hand side. Unable to row reduce to the identity matrix, therefore not invertible. Done. F&B 163. Let's get to the next problem. Yeah, it just depends, y'all. Like, linear algebra can be incredibly theoretical and abstract, or it can be very calculational. I'm working right now through an introductory book, and there are a lot of hand calculations in this, at least right now. But once I get to chapter 2 and chapter 3, it's going to get a little more abstract. But that's what made me fall in love with linear algebra, personally. So I don't know. I hope y'all give it a try. I tried studying tensor calculus, but it involved linear algebra too, so I had to drop it. That's the thing. Linear algebra is one of the most useful fields of math. It's so useful. It shows up in so many places. Even in engineering, it's more important now, I think, than calculus. Like, ChatGPT is just giant matrices. It's just multiplication of humongous matrices. It is linear algebra. Like, ChatGPT is linear algebra. AI is all so based in linear algebra. Like, anything computer science is so related. Data science, for sure. Like, big data sort of stuff. And M, it just says, it types it out, are integers, but I will use the fancy math notation for integers. In R2. So our goal right now is this a subspace? So if we want to determine if it's a subspace, the criterion is, two vectors, v and w, need to be in the set, and a scalar multiplication of a vector needs to also be in the set. So, for part A, let's work this. Let's take two arbitrary vectors. I'm going to use AB plus CD, and well, voila, if you add two integers, A plus C, whatever, and B plus D. Yes. A plus C is an integer, and B plus D is an integer, right? And then if we multiply a vector, Ka is an integer, and Kb is also an integer. Now notice that this is true if it's integers, which includes negative numbers, right? But this would not be true if these were the natural numbers or positive natural numbers, the counting numbers. It would not be true if we were working with n, also known as z plus or something. If we were working with the natural numbers, you can't multiply a natural number by, oh shoot, I take this back. This is not a subspace. What am I talking about? This is not a subspace because this is not a subspace because we can't multiply by a scalar, because the scalar needs to be in the real numbers. So yeah, so beautiful, by the way. Thank you very much. Do you like the presentation? Is that what you're saying? Or yeah, thank you. Okay, so let me see if can I move this back up here? I like it up there. No. For example, take pi times 1, 0 equals pi 0, and pi is not an integer. Yeah, my bad. Okay, so we are pretty much done. I ran out of time, so we didn't get to these next problems, but I'll just say it out loud that 1.7, try to work these next time that I go live. Welcome to my practice stream, everybody. Hit the like and subscribe, and let me know in the comment section if anybody is watching this after the fact. 1.7 is this optional section that's about application to population distribution, also known as, we learn about Markov chains. It introduces the idea of Markov chains. And then the next section, FMB 1.8.3, is going to be about Huffman error correcting codes. And this was all new concepts to me. My class did not do these optional sections, so it's really cool for me to be learning this stuff now. Thanks so much. Thanks so much for watching. If you enjoyed this, if you got value out of this, please like and subscribe, and consider sharing this with a friend. I would really appreciate that very much. My name is JC Practices Math, and I hope you enjoyed. I also have another channel called JC Practices, where I do the same idea. It's a practice stream in classical guitar. So if anybody is curious about that, go check that out too. Thanks for watching. Hit the like and subscribe, and I'll see you again soon. Bye.